today's job, I have compared an evolutionary model under several trees. Each tree has been made using different types of information. Now today I just realized I should probably also have some kind of control tree. So I'd like to run the model under so I've just made a random tree. Seems XML has an option to do this. So today's job is just to get this. So I just made a tree, and now I just need to get this thing integrated into this pipeline. So here's the command to make it makes a random start tree. If you use XML with the hyphen lowercase d, then it will make us start tree, a random start tree, upon which it does the branch swapping, so you can just initiate the program and then stop it. It just takes a second to actually make this random start tree. You don't need to go ahead and do the analysis on this. So this is what I've done. The file will be named this. So then I'm just copying this random tree into a different folder, and there's a bunch of steps we're doing. Now just one moment ago I actually ran this script and I got an error message. So I've just run this. First job is to figure out why this script is not running on this XML output, where it does run on the typical XML outputs, but for some reason it hasn't, is throwing an error message. So let's find this script. This is a Perl script, as always, as usual, called base traits wrap. As I remember, all this does is actually convert the format from Nuic to maybe Nexus, but let's just find this script and see why it's not working first. Here it is. Okay, now when I'm putting an error message, I usually put a number in there. I just put a line number. Doesn't matter if it's exact, but it just gives you a more precise way to find the error, line of the error. So I'm actually just going to put this in here, just any number, so when it prints the error message you can see exactly. But anyway, okay, so we have a subroutine for reading the string, Nuic string, removing any branch lengths and support values. These are not usually needed, and in this case I shouldn't have any. So we have a rather large regular expression for reading strings, which I wouldn't recommend. This is probably overly complex. It's actually kind of, when you come back to figure it out at a later time, it's really hard to do so. Okay, so let's work backwards. So it's attempted to parse a tree, and after doing the normal function, it has a look at a tree, but it still seems that there's still something left in the string which it's expected to extract everything from. So let's print. Maybe let's print the remaining string. And then stop the script. So it's not done anything. Okay, so it's all here. So you can see terminal is nuic string. Terminal names, as always, nuic separate. We have sets of parentheses to denote the structure. Now there's no branch lengths in here. Branch length will normally have a colon and a number. So no branch lengths, no support. This script seems to be expecting branch lengths. I see this semicolon here. So if that's the case, although no, it seems to be here, branch lengths should be removed. Okay, so only one function for. Okay, so we need to go through this step by step. First character, expecting an open bracket or close bracket or comma. Then some characters, either a lowercase letter or or a number. So for a start, I wouldn't expect this to be a normal terminal, because I usually have uppercase. Okay, I'm already a bit confused. So what I'm going to do, I think, is run this on a working tree and see what happens normally. So this has worked, and you go through this step at a time. Okay, so this subroutine, it's reading in tree into this variable called tree1. Then it's making a copy called tree2. But the branch lengths have been removed from the first version.
Oh, okay. So this is why I've got confused here. So these are not actually working on. These are not actually relevant for variable. So I should make a note of this. So branch lengths are removed from this. From tree 1, but this is working on tree 2, which is expecting. Okay, so this. So it seems the reason this is not working is because this is designed for trees. This regular expression was written with expecting branch lengths. Now this is a bit overly complex. I'm not really sure I want to try and remove this. And no, I've just realised I will actually need proper branch lengths in there. So I need a random start tree with branch lengths. And then, yeah, because we were modeling trait evolution, so this is not going to work. Okay, so let's go back up here. So reference tree 7, although this is a random tree, we've still got branch lengths will probably be all very strange, but still need to actually have some branch lengths on there. Still, it is a random topology. So we are having a branch length optimization under fixed topologies. A fixed topology will be the random topology. So we'll probably be using the -G switch. Let's just check this. This -H for the new frontier, some notes on XML. Maybe we need the -FE switch. Let's just try this. So we need a file suffix name, which needs to be slightly different moving before. Then we need the, we'll try the switch. Maybe we don't need a possum in the seed. Given him doesn't say what switch you need, maybe use -t for the fixed topology, which will be the random start tree. Choose this file name. Okay, let's move back into the other folder. Okay, see if this works. Because this is not doing any tree search, it's not doing any branch swapping, so it should be pretty quick. Yeah, okay. So here's our outputs. Let's have a, as I say, this is a random topology, but it should have branch lengths. I'm interested what this would look like. I guess the branch lengths will be very long. Let's find fig tree and have a look. Should be this one. Okay, yep, this looks pretty random. Well, I'm looking at this. I hope these are. I hope this is not a poly. This looks like a polytomy. I hope that if these are just zero, if this is fully bifurcating but just zero branches, zero length branches, this is fine. But if this is actually a polytomy, I'm not sure that will run. So I might have another problem here. Let's. Okay, stop this. Let's have a look at the file itself. Maybe this is not actually polytomies. These are just very small branches. Yeah, I don't see any polytomies. Oh, maybe this is fine. Okay, so So now we have a control tree, which is called, this is another file name with some branch links on there. Back into we're switching a bit with directories, but it's good to organize. You don't want to do a whole project in one folder. You can end up with a folder with a million files in there. Let's do some kind of separation, which makes things a bit easier. So I have now RT, this means reference tree 7, so we've got a bunch of trees. This will be the standard tree, which has various information content gone into making this, and different informational modules for some sort of testing the effects of these information modules. And we have here a tree which will use as control. So let's try again on this one, which we've done the branch length optimization on, and see if this. So I don't need this anymore. No error message. Our new file name in here. Just trying to figure out what I want to remind myself what I've done. Okay, so what I've done here is I'm writing this is for Bayes traits, which is for trait modeling on a phylogeny. Got standard software. Now, Bayes traits, it requires a file in which is write all the commands. So actually I do use echo Linux command to write the file. So echo, so it's specifying option 1 for Bayes traits, and the second line to set in a number of iterations in the Bayesian chain, sampling, burning, and saving the model. Okay, here's what I'm getting confused here. So here is these names. So okay, yeah. So we've created a Bayes traits format. Well, I can show you the format used by Bayes traits. I think it's Nexus. Yeah, so Nexus, it has numbers corresponding to the on the tree string, and then specify the name of the terminal. not so widely used as phylip. Anyway, so we've made a nexus format tree, then run base traits under this tree and use the commands. So all these echoes, we should just written these commands into this file here, btcommands.reftree, and then running that command file here, and then bt is another import. So this is the trait data which is specified elsewhere. Okay, so this looks fine. I'm just going to, so it's specified our new reference tree, which is the random tree, and we need to, we're creating a model for under this tree. Now this is a very strange tree. I'm not sure what will happen, but I'm going to see if it starts at least, which it does. So this is base traits, screen output. Yeah, this is incomplete trait data, so I think that's what this is here. And we're running the model. So I've done quite a lot, quite a long chain, 50 million, whatever is in whatever we call these. I forget, MC or something. So yeah, this is going to take a few hours, maybe a few hours to run. But maybe that's enough. So this seems to be working. So maybe the later parts of this analysis I'll cover, maybe detail in some later time. But briefly, what we've done today is incorporated a new topology into a pipeline where we are assessing a model of trait evolution, and we'll try and incorporate this random topology as a control and see what this does in the results, which I will cover at a later time. Okay, enough for today.